Well, hi again, this is Bob, and we're getting ready to look at section 3.4, which is more on graphing. And this time they're going to teach us a method using the intercepts. Remember that we introduced the concept of x-intercept and y-intercept in a previous lesson. Just to review where we've been for the last lesson or so, we had an equation, something like maybe 3x plus 1, and then we chose a few values of x, like maybe 0, 1, and 2. Then we found out their corresponding y values. For example, if x is 0, then y would be 1, and if x is 1, then y would be 4, and if x is 2, 3 times 2 is 6, and 1 is 7. Okay, and then what we did is we found those points, like I say 0, 1 is here, and maybe 1, 4 is here, and 2, 7 is up there. Remember, we only need 2 points to determine the graph, but we chose an extra one just for insurance purposes. Okay, and that's the main thing that we did in the last section, is we found out, or we drew the graph by choosing some values of x and plugging them into the equation. And notice that in this equation, y is by itself, but we also know if we had an equation like minus 3x plus y equals minus 2 or something, that we could easily add 3x, in this case, to both sides and get y by itself. And then we could go and start plugging in our x values again. And by the way, for the last little thing, we learned when y was by itself, if we had a number in front of x, which they usually call m, and I'll give you a little hint for this lesson that m is going to be introduced shortly as slope. But the coefficient of the x term when y is by itself, if it has a fraction like the 2 in the denominator there, we would try to choose values for x that go evenly or divisible by 2. So maybe, I'm not going to do this question, but just I'll give a few that we would choose. Maybe like 0, 2, and 4 would be good candidates to plug into that equation where y is by itself. Okay, well that brings us up to date. In fact, I usually call that method 1 in terms of solving an equation, or excuse me, graphing an equation. Now, here's another method, and it uses the intercepts. And over on page 183, they review our definition of intercepts. The x-intercept, for example, this is just theory talk here, but the x-intercept, somewhere on the x-axis, where x is some actual number and y is equal to 0. And this is called the x-intercept. And the y-intercept is where x equals 0 and y is equal to some number. We're just using a and b as generic placeholders there. So in this case, this would, where the graph cuts across the y-axis, that's called the y-intercept. Now, just so you know, I could easily draw a graph something like this one here. And I could say that this point here is 0, 5. And this point right here is 3, 0, and then draw a line through them. Okay. Well, this is the nice thing about intercepts. When we have the x and y intercept, those 2 points determine a line, and so in this method we only need 2 points, and we hook those 2 points up as carefully as we can with a ruler, and that is indeed our graph. Okay, now I haven't told us what the name of that graph is, but we're just still doing a little bit of theory here. Okay, so anyway, we now know what the intercepts are, and the x-intercept will always be where x equals some number represented by a and y equals 0. And the y-intercept will always be where x equals 0 and y equals some number, and we call that number b. So let's go look. This is a very straightforward and rather short lesson here because it's one skill. And the other thing I need to mention is when we're going to use this method, we want the equation in standard form. Now, we can use the other form where y is by itself, but normally we might choose to use this method when the equation is in standard form, or we can get it into standard form by doing a little not substitution, but rearranging. Okay, here's our first example on the top of 184. We're supposed to find the x and y intercepts for 3x minus 2y equals 6. Okay, so the first thing that they tell us to do on these, now you can do it, what I like to do is I like to use, since we've been using this little skeletal arrangement for x and y, I like to explain this as we let x equal 0 and then see what y is, then we let y equal 0 and see what x is. And what the book does is they go like 0 and then we find y, and then they give us 0 for y, and then we find the x value. But what we're going to do is successively let x and y go to 0, and of course that term will drop out of our equation, and then we can solve for the variable. So let's let x equal 0. 3 times 0 minus 2y equals 6. Well, of course, 3 times 0 is 0, and that leaves us minus 2y equals 6, and we can simply divide both sides by minus 2, so y equals minus 3. So when x equals 0, y equals minus 3. We can put it right here also. Now, how about if y equals 0? 3x minus 2 times 0 equals 6. In this case, minus 2 times 0, of course, drops out, and we get 3x equals 6, and we can divide both sides by 3 and get x equals 2. Okay? So, this is the way I would normally write it on the left here, and I'll put it in a box, but you can use the book's way also. It's basically the same way. So our intercepts are at 0, negative 3, and 2, 0. So then we just draw ourselves a graph. You'll be using graph paper, of course. But here's where 0, negative 3 is on my graph, and here is where 2, 0 is. Then I can draw a line through them. And that is the graph of 3x minus 2y equals 6. Now, we know a lot about that graph. We know it stretches infinitely in both directions, and at any point on that line, or the graph, that we would plug in to 3x minus 2y equals 6 would satisfy that equation. And we know that there are an infinite number of those because this line is composed of an infinite number of points. Anyway, that's pretty much it. Let's take a look at example 2. This is at the bottom of 184. Negative x plus 2y equals 4. Now, you know, in my mind, I can let x equal 0 and see that y is going to be equal to 2. And maybe after you have done a number of these and feel really comfortable with it, you can shortcut this a little bit. But I'm going to try to be as careful as possible in doing the questions exactly like the book asked us to do. Remember, I let x equal 0 and find out what y is. That gives me the y-intercept. And then I let y equal 0 and find out what x is. That gives me the x-intercept. So here's where x is equal to 0. Okay, well that's just the same thing as 2y equals 4. That cancels, or drops out, and y equals 2. So there's my there's my y-intercept at 0, 2, and now I let y equal 0. Well, 2 times 0 is 0, so that drops out and leaves me the opposite of x equals 4. And remember, my way of dealing with this is to put a 1 after that negative sign because it's always there. And then that's like minus 1x equals 4. Then divide both sides by minus 1. I get x equals minus 4. So we have 2 points, and that's just enough to draw the graph. And we would find 0, 2, which is our y-intercept. And then we would find minus 4, 0. It's our x-intercept. And then we would draw a line through those. Again, you'll be doing it on graph paper. Okay. Now, there's two schools of thought on this one, but I'm going to follow the book's example here. Let's take a look at example 3. And I'll just give you, I'll just digress for a second. If we had something like 3x minus 2y plus 6 equals 0, and somebody said to graph that, well, you could get y by itself, but it'd probably be easiest to think about using the method we're doing and just moving that 6 by adding its opposite over to the other side. And that would give you 3x minus 2y equals negative 6, and then you could attack it using our 0, 0 or intercept method. Okay, now, but on example 3, they give us y is equal to minus the third x plus 2. Now, personally, I know a couple of other methods, like the y equals mx plus b method, or they've also just shown us in the previous section how we can choose 3 values for x and plug them in and get corresponding y values and do the graph. But in this particular problem, they want us to use the 0, 0 method. And it turns out that we really don't have to rearrange this into standard form. Remember, standard form is ax plus by equals c. Okay, it turns out we can still plug 0 in for x and y and solve back for the intercept in question. And I'll start off by let x equal 0. Y equals minus 1/3 of 0 plus 2. Of course, that would give us y equals 2. And then we let y equal 0, and that gives us minus 1/3 x plus 2. Well, we'd have to solve that by adding a minus 2 to both sides. Minus 2, minus 2. And that would give us minus 2 equals minus 1/3 x. Okay, then of course the last thing we would have to do is multiply both sides by minus 1/3. I'm sorry, by minus 3. We get down toward the end of the paper there and or into the screen and make a simple little mistake there. Okay, so we already knew this. We already knew that when x is equal to 0, that y was equal to, when y is equal to 0, when x was equal to 0, y was equal to 2. Okay, then we had y equals minus 1/3 x plus 2. Okay, so now what we wanted to do was let y equal 0 and find out what x is. And this is where I wrote the wrong reciprocal there. Okay, so 0 equals minus 1/3 of x plus 2. Then I would subtract 2 from both sides, and I'd get minus 1/3 x equals negative 2. And then, of course, I would have to multiply both sides by -3. And this would cancel and give us x equals -3 times -2, or +6. So we would have the intercepts 0, 2, and 6, 0, and that is what would determine our graph. 0, 2, I'll say, is right here, and 6, 0 over here. Pin seems to be, there we are. Okay, so there is our graph of y equals -1/3 x plus 2. Okay. And that should look exactly, or pretty close, because I don't have the grid there. But if you take a look on page 186, you'll see that the graphs are the same, only theirs is a little bigger and a little nicer looking because they used the graph paper. Well, that's the examples, and I've got a few homework problems picked out to do. How about question 2, and this is on page 186. Now we're supposed to find the intercepts and then do the graph. Okay, so there's my reminder of what's going to be happening here. Now again, if you want, you can use, it's the same thing. You can write the x and find the y, and then plug in 0 for y and find the x. Okay, on this one, I'll make that a little 0 for x, and we're looking for y. And this one would be, we're looking for the x value, and we're letting y equal 0. That's what I'm basically doing with this diagram up here. Anyway, let's let x equal 0. 2 times 0 plus y equals 2. So 2 times 0 is 0, so y just equals 2. And then we let y equal 0. 2 times x plus 0 for y equals 2. Well, then that drops out and gives us 2x equals 2, or x equals 1. So our intercepts, where the graph crosses the x and y axes, 0, 2 is our y-intercept, and 1, 0 is our x-intercept, and then we would hook them together. And this is the graph of 2x plus y equals 2. How about question number 6? Minus x plus 2y equals 4. When x is equal to 0, we would get the opposite of 0 plus 2y equals 4, which is just the same as 2y equals 4, or y equals 2. Now, when y equals 0, 2 times 0 is 0, and we get the opposite of x equals 4. It's like a 1 after that opposite sign in front of the x, so we would divide both sides by -1, and this gives us x equals -4. So then we can graph these, or plot these intercepts. 0, 2 on the y-axis, and -4, 0 on the x-axis. Okay, so the graph would look something like that. Okay, Let's take a look at question number 20. 20 is like the, oh, I'm sorry, I wanted to look at 12 because it involved a fraction. 12 is minus 2x plus 3y is equal to 3. Okay. If x is equal to 0, then 3y equals 3, or y equals 1. There is our y-intercept. Now, if y equals 0, then we get 3 times 0, which drops out and gives us minus 2x equals 3. And then when we divide both sides through by minus 2, we get the x-intercept as 0 for y and minus 3/2 for x. Well, we just don't have any choice on this one. We're going to have to try to graph a fraction on the graph. So here is 0, 1. 1, 2. Okay, minus 3/2 is the same thing as minus 1.5, so it's halfway in between minus 1 and minus 2. Now, you might say it's splitting hairs a little bit because that dot sure looks like it's halfway between minus 1 and minus 2, but it might be a little more than halfway or a little less than halfway, and the idea is still the same. We can't plot it exactly, but as long as we understand this, we'll just move on. So there's the graph hooked up. And that is the graph of minus 2x plus 3y equals 3. Okay, now we'll take a look at question 20. Question 20, y equals negative 2x minus 1. Now, this is the one that we learned we might normally, in the previous section, we would have said, good, the y is by itself, and we would have maybe chosen 3 simple values and plugged them in. Now we want to use the intercept method, and we don't want to get this into standard form. We want to leave it in this form. Okay, so we'll start off with x equals 0. Y equals minus 2 times 0 minus 1. That would cancel out, or minus 2 times 0 is, it would drop out and leave us y equals negative 1. Okay. Then when we plug in y is 0, we get 0 equals minus 2x minus 1. Then we would add 1 to both sides, and we would get 1 equals minus 2x. And then finally we would divide both sides by minus 2. And x would equal minus 1/2. So we would be finding, we're going to have to find a fraction again, but that's okay. 0, negative 1, and minus 1/2, 0. I'll say that's about right here. Okay, and there was our graph. That, in fact, I like to write what the name of our graph is just to reinforce this idea. That is the graph of y equals minus 2x minus 1. Okay, let's take a look at question number 26. Now, on 26, they give us y is equal to half x. Now, I think if you recall, this is a graph that's going to go through the origin. Remember, if we use this method, this is overlapping a little bit from the last section, if we let x equal 0, a half of 0 is 0. And of course, if we let y equal 0 and solve back, we end up with, multiplying through by both sides, we end up with x equals 0. 2 times 0 is 0. Okay, so we've got 2 points, but they're the same points. In other words, one sits on top of the other, and they have to be 2 different points. So in this question here, with y equal 1/2 x, we can't use the intercept method. Okay, we can get one intercept, we can get the origin out of it, but we need to adapt our method a little bit differently here. So we'll go back and use our previous method, and I'll just use one other point here. Okay, we know that when x is equal to 0, that y equals 1/2 0 or 0. Let's just pick another value for x, like x equals 2. Notice I didn't pick x equals 1 because that would yield a fraction for y. And if y is equal to, if x is equal to 2, then y equals 1. So we would go find the point 0, 0 and 2, 1. And I'll do that on the top of the next screen. Okay, so there is the graph of y equals 1/2 x. And it turns out that we are not able to use the intercept method on that because it goes through the origin. So if we run into another case like that, which you will on question number 28, or sorry, question number 29 and question number 27, question number 25, all you have to do is just find another point using a previous method. And you know, that brings up another a good observation here. When you have an equation to graph, you will really have 2 or 3 methods at your disposal to choose from. And unless somebody tells you specifically which method to use, you're free to use any method that you like, as long as the graph is accomplished. And some people are partial to, if there's 3 methods, some people are partial to a particular method and use it all the time, and that's fine. Of course, or unless, of course, they're asking us to demonstrate that method on the homework. Okay, last couple of questions. I wanted to take a look at question 37, even though you'll be doing it, but I've asked you to do 38, and they're alike. It says graph the line that passes through the points -2 and 5 and 5, -2. And then give the intercepts. Now, I can't do this, obviously, as good as you'll be able to, but I can show what they're looking for here. Okay, the point 5, -2 is right here. And the point -2, 5 is right here. Now, when I draw a line through there as best I can, that line is going to pass through the x and the y intercepts. And they want to know what the x and the y intercepts are. Now, I'm off on my graph here, but I can tell you that the x-intercept would be at the point 3 for x and 0 for y, so I wasn't really that far off. And the y-intercept is going to be at positive 3. Well, I'm more like 2.5 or so, but its coordinate would be 0, 3. So even with this crudely drawn graph here, I got pretty close. So the x-intercept is 3, 0, or x equals 3 if you like, and the y-intercept is 0, 3, which is the same thing as saying y-intercept is 3. X-intercept is 3, y-intercept is 3. And I've asked you to do 38 for your homework question that you'll be giving me, and it's done the exact same way. Okay. Let's take a look at question 40. Now, question 40 what they want us to do here is give the x and y intercepts. And it'll be, all you have to do is look in the book. Okay, but here's what they've given us on question 40. They've given us they've given us that graph on coordinate paper there, or in your book. It's coordinized, or we have using the x and y axes here, and they want to tell what the x and y intercepts are. Well, the x-intercept is at 1, 2, 3, 4, -5. X-intercept is -5, and the y-intercept is at -3. So you can read that directly from the just by looking at the graph. Okay, that was 40. You're going to look at 39 and just tell the x-intercept and the y-intercept. You can just write x-intercept equals, or you can just give the coordinate also. Okay, well, I think that's just the right amount of this, and we're going to look at 3.5 next, which formally introduces the idea of slope. So I guess I'll close off this lesson by telling you that the letter M stands for, is the mathematical abbreviation for slope, and we're going to be introduced to a formula for finding slope, and that's going to set up the third method that we can use to draw a graph. So I will be back shortly to discuss that. Thank you.